The broadcast is now starting. All attendees are in listen-only mode.
Okay. Uh, you probably can hear me now. I hadn't unmuted myself. Attendees, you are all muted. Uh, you can only ask questions by typing in the questions pod. In November, we have the Past Community Summit, October 31st through November 3rd. And if you register for this, you can save $150 by using the code. I'm including that code in all of the mailings as well. So go for it. We will get a complimentary summit registration for every time 20 people register using this code. and then we will raffle those off when we get closer to the event. We are one of many virtual groups. If there are things that you are interested in besides database administration, go to your past profile and check them off and get on their mailing list. If you're not familiar with SQL Saturdays, they're one-day free training events. They're all over the world, as you can see, and they're like a mini conference. I know in the one in Philadelphia, we usually have 6 different tracks with 5 different presentations in each one. There are many local chapters. Unlike this virtual group, the local groups have face-to-face contact, quite often have refreshments and opportunities to meet people in your area, your region, who share your interest in SQL Server. PASS is an all-volunteer organization, and you can volunteer to serve for an hour at Summit or on a long-term basis like the people who run virtual groups and so forth. This is not for those of you who are here, but people discover us on YouTube. And that's because YouTube is the vehicle we use to get the recordings of the sessions onto our web page. And if you're viewing our recording on YouTube, join PASS. It's free, and you'll be able to download things like supplemental scripts used by many of the speakers. As I said, it's free membership. And now I am honored to turn the meeting over to Toyab Ali. He's an accomplished technical leader with proven record of success. His experience includes 3 major business sectors: financial industry, e-commerce, and healthcare. He's Microsoft and Mongo certified data professional and has over 11 years of IT experience. He has hands-on experience in managing large database projects, including large data migration, complex process design, testing and deployment, performance tuning, and long-term capacity planning. He's currently working as a DBA lead, focusing on automation, improving and streamlining operational workflow, and planning and preparing for cloud migration. He's a regular presenter at user groups and SQL Saturday events. And so let me make you a presenter, Toya, and you can go to it. I'm not hearing you, Toya. Okay.
Okay, how about now?
Yeah, that's good.
Okay, and can you see my screen?
Yep.
Okay, thanks. Thank you everybody for joining. Good afternoon if you're in East Coast, and good morning if you're further west. My name is Thoyob, and as Sharon said, I work as a lead DBA at a financial industry, and we have about 50 minutes left, and we'll be talking about Cardinality Estimator. And before we go there, so as you know, a little bit about me. I'm working as a DBA close to 11 years, certified in SQL Server 2012 and 14. And before that, I worked in Merchant Navy for 10 years. Outside work, I do run a lot. I did one full marathon and a couple of half marathons. And any other time that I have, I'm busy with shuttling 3 kids around their activities. And I also get involved with the SQL Server community. Frequently speak at a group and SQL Saturdays. As Sharon was saying, I'll be in Rochester this weekend delivering 2 sessions in the SQL Saturday there. I do answer questions in Twitter using SQL help hashtag and also in dba.stackexchange. I blog at sqlworldwide.com. So these are some of the topics, or all the topics that we'll talk about today. And the reason I picked this topic and these items particularly is the Cardinality Estimator, when it makes a decision about the estimated rows that we see in the execution plan, and we'll see it in the demo, these are some of the things that it takes as an input. And if the input is not good, we're not going to get good results. And if our estimation are not correct, there are other consequences that we'll be seeing during the presentation. And all the codes will be available, and I'll send those to Sharon, and she'll send you an email with the link, also with the slides. And right now, as you are joining this meeting virtually, I would request you to go to this link, and the case matters at the end is SWWC is in uppercase. And if you go towards the bottom of that post, you will see a download, which is an output of a DBCC show statistics that we'll be using in the demo. So I think it will make life a lot easier when I'm referring to this. You will be able to follow my presentation a little bit easier. So first, let's talk about a predicate. A predicate is an expression that will evaluate to true, false, or unknown. And for our purpose as a data professional, we have 2 different types of predicates. One is a join type that we use in different joins. Other one is a filter predicate that we use in where clause and having clause. And this is an example of join predicate. It's a simple select statement with joins between 2 tables, orders and customers. And as you can see here, our join predicate is a customer ID, which is a common column between both tables. And on the filter predicate, we are using the order date. And after we group by, we are only looking for where the counts are exceeding 2. So this is just, I'm just trying to build it up from ground. So we'll first talk about a few terms, then we'll put all those together towards the end. The next is density. So density is used to describe the data in a column. It's a measure of how often duplicate values occur in that column. And we can find the density by 1 divided by the number of distinct values in a column. So in this case, for order table, and all these tables I'm talking about Worldwide Importer, which is the new sample database from Microsoft starting SQL 2016. Of course, you can use it with any other version. So Microsoft came up with this new sample database, and I'll have a link where you can download a backup for this database in the resource page. This is a plan to replace AdventureWorks. Of course, you can still restore AdventureWorks in SQL 2016 also, but all my demos are based on the new sample database. So here, if we look at the distinct customer ID, and if we do a count, that's 663 records, and if we divide that, then we find the density of customer ID column. And we talked about predicate, we also talked about density, and we're also talking about Cardinality Estimator. So if we have to put this all together, for us or for the data professionals, a predicate selectivity is a very high implication, as we will see during the entire presentation. And selectivity used to describe a predicate. So the most selective predicate will have less number of rows. So in this case, if we see that if we do a count on the number of orders and our predicate is customer ID equal to 577, and we only qualify for 75 rows. So what this is telling us that our predicate selectivity is 75 out of 73,595 total records. And if we divide that, then we get the selectivity is 0.0010. And what's cardinality? So cardinality, this term is used in different ways for different professionals, right? So I put 3 definitions here, just for your information, but we are mostly concerned with the first one. What we're talking about is for any of the operator in a query execution plan, how many rows we get as the input and how many rows qualify or how many rows are going out. That's what the cardinality is for that operator. And if we talk about in terms of a table and different columns in a table, then we can say the uniqueness of the value in that column is the cardinality for that column within that table. And there's a mathematical definition also I put, it's a measure of the number of elements in a set. So I think most of us are familiar with this picture. If you open an execution plan and right click on a node or on an operator, then you see 2 different cardinality. One is the actual one and one is the estimated one. And I'll show this to you in demo if you don't know how to go here and how to look at those. So what happened in this case, this operator, the Cardinality Estimator estimated that it will qualify for 7.615. Of course, that's not possible to see there. It's probably 8 rows. And we see this number in a decimal format because it either has a formula to calculate, it's looking at the statistics, or it has a fixed number that it's using to estimate that number. But the actual rows that qualified for that operator was 12. And we can see the difference. And in this case, the difference is about 4 rows, which is still a 50% if we compare 12 and number 8. And based on this difference, or if this is the difference is small or big, it has implications on the overall execution of the query. And that's why I think this topic is important. Now, what you can do, like, if you're writing code, if you know that how these estimates are created, there will be situations when there will be no statistics, or your statistics will be based on a sample data, or you might have an unknown value, which you'll see as we progress. You have some idea, or you know that how this is going to calculate, and based on that, you can adjust your code, or you can make some decisions to push the estimation to be as close as possible to the actual numbers. So what happened when we submit a query to the SQL Server engine? It first go to the parse and normalize, and I'm not going to go into very details of this. I put a link in the resource page because that's not the topic of this talk. If you really want to dive into each phase, you can read the article that I added in the resource list. But just give you an overview. So the parse and normalize. The parse will check the syntax like spelling, correct keywords, and all those. And the normalize is going to check whether the tables and the columns that we mentioned in our query exist. If it has a view, it might change the view name. It might change that view name and replace it with the full view definition. It might replace a subquery with a join. Once this phase is done, then we go into the cardinality estimation. And it derives the cardinality, and then it creates many plans, many possible plans. And SQL Server Query Optimizer is a cost-based engine. And it looks at the cost of all those plans. Out of those, it picks the cost plan. And based on that plan also, it grabs other resources that it needs. To give you an example, it will grab memory depending on how much memory it needs to execute that query. If there is a sort operation, then it will grab memory based on the estimated number of rows to be sorted. And then once it does all that, then it goes to execute the plan. So the reason I put this slide, what I'm trying to show you is that after the cardinality estimation, there are downstream events that's happening when our query is getting executed. So if this estimation is wrong, or if this estimation is way off than the actual number of rows, there are implications down the stream when your query is really getting executed. And these are some of the items that I put that will get affected based on the number of estimated rows or the cardinality estimation. If your operator is going to go parallel, or is it going to run in serial fashion? Of course, it depends on your max stop setting and also your cost threshold or parallelism. But all those will be calculated based on the estimated rows. We talked about memory, how much memory grant is going to ask for. And if it doesn't ask for enough, when you go to do the sort is going to spill to your tempdb, means to your disk, not in memory. And that's going to increase your runtime. Is it going to do a seek or a scan? What kind of join it's going to do? How it's going to do the aggregates? All of these decisions will be based on your estimation. And that's why if we know how the cardinality estimator is going to estimate the rows, and when we see that we are expecting a scan and it's doing a seek or vice versa, we can go and look at the differences, and we know how it was calculated, and then look at our query, how we wrote it, and see if we can make some difference or change it. Now, a bigger part of cardinality estimation, out of all the inputs, I think the major input comes from our statistics. And for all the indexes, the statistics get automatically created, and there is a setting in your database that create auto statistics, and I hope nobody turned that off without a very valid reason. I haven't turned that off ever. And once you have it on, turned on, and if a query is looking for a statistics and it's not there on a column, it's going to create it. And we'll spend some time looking at the output of DBCC show statistics, because I think it's paramount that we understand this output to look at some of those numbers from the query, from the cardinality estimator. So DBCC shows statistics, and if you looked at the page that I asked you to download at the beginning, I put the query that is showing the DBCC show statistics for sales order table for one of the statistics or one of the indexes. And it has three different sections. One is a header, one is a density vector, and one is a histogram. And we'll look at all three in details. And that is how it looks like. For the histogram, you get 200 steps. You can get less based on your data distribution or based on the number of rows, but doesn't matter. Even if you have billions of rows, you never get more than 200. That's the maximum steps that you can get. So let's look at the stat header. So the first one is your name, and then when it was last updated, how many rows. And in this case, just for the demo purpose, if you look at this screen, look at the number of rows is 50,299, whereas my unfiltered rows is 73,595. So what I did here, I created a filter index, and you can see the filter expression. I said contact person ID is more than 2,000. So this index was created with the rows that qualify where contact person ID is over 2,000. But if you don't have a filter, your number of rows will match unfiltered rows. And this is a small table, so I did create the, I did update the stats with full scan. And sometime you will see the number of rows and number of rows sampled will be different. And you can always hard code or, and tell with how many % of rows you want to create your statistics. And by default, it's a sample, I think it's 2%. And there's a deprecated column, which is density. Microsoft suggests not to use this. This was, I think, since after 2005, it was deprecated. And average key length is the average number of bytes that this status or these columns are taking. The next one is a density vector. As you can see here, the contact person ID is 1 divided by number of distinct values in column. We saw that before. That's how you get that number 0.0021645002. And as we know that every non-clustered index also has the clustered index column appended to it. So we see another row, which is an order ID, which is the cluster index or primary key in this case. And both of those together, we get the distinct number of rows, and divide by, 1 divided by that, we get the other number. And as you can see, the average length is 4 and 8 because they're both integers, so each take 4 bytes. So 4 and 8 is the number of bytes for those columns or column combinations. Next is a histogram. So as you see, I highlighted 2 of the rows, and what I'm going to do, we'll look into a little bit more details into these 2 rows, and I'll explain you each of those numbers, what it refers to. So as you can see here, or you can also look at the downloaded paper between row number, on the histogram between row number 10 and 11. So the range high key is 1055 and 1063. They are a real value for contact person ID that exists in that table. And first, let's look at the equal rows. So equal rows 126 means we have 126 rows where contact person ID is equals 1055. And that's true also for 1063. We have 139 rows for contact person ID 1063. And let's look at in between. So the range rows and distinct range rows and average range rows, these imply to anything where contact person ID is between 1056 and 1062, meaning excluding those range high keys. So 356 means we have 356 rows where contact person ID is between 1056 and 1062, and between is inclusive in TSQL term. Distinct range rows means if we do a distinct of contact person ID between 1056 and 1062, we'll see there are 3 values. And if we divide the range rows divided by the distinct rows, distinct range rows 3, we get the 118.6667. So what will happen if we pass a value in between, anything in between 105 and 1063, the cardinality estimator is going to estimate that we have 118.6667 rows, and that's how sometimes you get these decimal values. Though, when we get our results set, we don't get half a record, we get the full record. And we'll see this number in our demo and when you go there. And ideally, I don't know if this is the right term, magic numbers. What I'm trying to say is all those numbers that we get, some are, we'll get it from histogram, and some are really using some formulas, and they are pretty fixed value. Doesn't matter what we pass. And these are some of the things that I'll show you in demo. And there are more. So look at all those when you go to the demo. And that's where we'll spend probably most of the time that we have remaining, another 30 minutes. Sharon, any questions so far? Maybe we can take one or two if there is.
Not yet.
Okay, great. So I'll move to the demo then. Okay, so the first slide, what I'm doing here, you can get the backup, as I mentioned before, worldwide importers. This is the link. And I already did this to save some time. So I'm just restoring the backup, and I'm updating statistics for the sales.orders table. This is the table we'll use throughout the demo. So the first thing I want to show you that all the numbers that we saw in the output of DBCC show statistics for orders table, FK sales orders, contact person ID, how these numbers are generated, and what the formula is behind that. And we have seen some of those, in our, when we looked at histogram, and I explained, but I'm also creating those same numbers here. And once I run this, I'll show you the output, and then we'll talk about those. So the first one in the stat header, a column name updated, as we said, it just tells us that, as you can see, when it get updated, the number of rows is the total number of rows. The density vectors are 1 divided by number of distinct contact person ID. And if we go here, that's what I did here for the density. We took 1 divided by the count distinct of contact person ID, and that is how we get this number. And for the next one, we said number of distinct between contact person ID plus order ID. Let me zoom in a little bit. And on the histogram, we looked at the range rows 338 between 1014 and 1020. And if we go back here, I'm just saying, count contact person between 1014 and 1020. And then we get that number here is 338. And if you look at the downloaded paper, you'll see it there in row number actually it's a little bit different, so let me you'll see there. And then the equal rows, as we said, it's exactly what's equal to 1021, and it's 113. So if you look at the row line number 4 in the paper, in the histogram, you will see that For 1021, we have equal rows 113, and then the distinct range rows is 3, and then the value is 112.6667. And what I was talking about is right here. These are the numbers we saw in that, the 338, 1133, and 112.6667. So you can always, go back and look at this code and see how all those numbers are generated. The next thing we'll look at is a single predicate. So again, we are using the worldwide importers, sales order, contact person ID. So this is a direct hit for our histogram. If you look at that, line number 5 is a 1025 is a high range high key, and if we come here, we talked about before, where to look at. I show you a picture before. As you can see here, the estimated number of rows is 89. That's right here. And in this case, we have a match because we just updated the stats. Sorry. The actual number of rows is also 89. And where this number is coming from for the estimated, if you look at the page and look at line number 5 for range high key 1025, which is a 89. So it's a direct hit and it's getting it from there. Now, up to SQL Server 2014, if your auto update stats are turned on, stats get updated when 20% plus 500 rows are modified or inserted yeah. But in 2016, that number changed because chase flag 2371 is by default is turned on in 2016, or it's incorporated into the engine. So as your tables grow bigger, that number will come down. But in our case, what I'm trying to show you right now, if we insert 2,759 more records into this table, then what will happen to that estimation? So let's do that. So I'm just inserting okay, and let's look at that. So as we can see that it did not change. It's still saying 73,595 records, and the updated time is about 3 minutes before. So the stats didn't get updated. And now okay. See, this number get changed, 92.3365. Even though we are still passing 1025, and if we look at our stats, for 1025, our equal rows is 89. So where is this number now coming from, 92.3365? What it does, when you have new records, it does do a sliding math. So what it does, it knows that it's 89 records. It knows this number, which was the total number before it did the insert, and then it divide this to multiply by the new count of the total records. So if we run this, we get this number, 92.3365. That's how the estimated number got increased to from 89 to 92. Of course, once we do the insert, our total number of records we get back is way more high, 2,848. But our estimate, of course, didn't catch up. So the estimate was 89. From there, it increased to about 3.3, even though our number of records increased from 89 to 2,848. So it does some increase, but not, not to the level that we want. And for that to be accurate, we can either, rebuild, update our statistics, or if it hits that threshold, then it's going to do it by itself. So let's put things back together for the demo. So next we'll look at, for contact person ID 1057, if you look at the histogram, there is no range high key for 1057. So 1057 falls in between line number 10 and line number 11, which is 1055 and 1063. So let's see what happened in this case. So you get 118.667. So what happened here, if you look at the histogram between these two, you will see that in the line 11, our average range rows are 118.6667, and that number came from range rows divided by distinct range rows, and that's how it picked up that number. And next we'll be looking at distinct values. So we know that contact person ID is the column for this statistic. So if we run this, and if we're looking at the distinct for all those, we get the number 663. Right here. So this came from, if you look at the density vector for contact person ID is 0.00150826. So it's a reciprocal of that number. And that's how it picks that 662.9998 and round it to 663. So that's all I have for single predicate. Now we'll be looking at some of the multiple predicates. And things changed here between 2012 and 2014 with the new Cardinality Estimator. I'm not going to demo the previous engine, but I have some code here that I commented out at the end that if you want to test this for 2012 and below, you should be able to run it. Even if you don't have a SQL Server in 2012 version, if you have 2014 or up, you should be able to run this, use this trace flag to test it the way that it will act like it's a 2012 version. So you can mimic that with that trace flag. Sharon, any questions so far?
There's a couple of questions.
Sure. Let's take one or two.
Okay. The first one is, how does the optimizer behave differently in column store index operations?
So in column store, the data is totally differently laid out compared to what we are looking at, right? we are here, the data is laid out in a row format. So even though you ask for 1 or 2 columns, the whole row needs to be picked up to the memory. Whereas in column store index, you just get those columns that you asked for, and it's compressed, and it's it's more efficient. So if I'm asking for, just to take this example, if I'm asking for these 4 columns, column store only going to bring those 4 columns vertically. But in our case, it has to bring all the columns, for the pages that are in between 1024 and 1027. Then it's going to only pick these 4 columns. So, I really cannot, show a demo here with the column store index because it's not set up that way. I haven't set it up, but just in general, it's a lot more efficient, a lot more faster, because the compression rate works a lot better because the way the data is laid out in the disk. Let's take another one, Sharon.
Okay. What's the moment when the histogram changes?
So anytime your stats are updated, whether you do it manually or your auto update stats kick in, your histogram will change.
Okay, and I got one more.
Sure.
Please describe the change in the optimizer's behavior when using literal values versus host variables. For example, where order date greater than equal to, quote, 201400101 versus where order date greater than or equal to add input order date.
Sure. So we'll see those in the demo. So hold on to that question as we move forward, as we look at to the unknown values. And I will also show a store procedure call and how it, how things differ. I think that will clear this question a little bit. Okay, so we'll move on. So these two, I already wrote the numbers. I'm not going to show this, but if we combine this predicate and this predicate with a AND, what's going to happen? So let's look at that. So here, our estimated number is 44.4052. Now, how did we get to this number? And we're going to use these two numbers. So in 2014, what the change is, they call this exponential backoff. So before 2014, the Cardinality Estimator will estimate or will assume that we'll get same number of records from this and from this, and they will treat those equally. But in 2014, what they did is they said, okay, if my selectivity is say like, S1, S2, S3 to Sn, I'm going to treat those differently. So I'm going to take the most selective one at the beginning, but to reduce the effect of other ones, they are less selective. I'm going to put a square root on those, and the next one is a square root, and that's how it's going to diminish the effect of the most of the least selective ones. So that's the difference. So I put here both formulas for 2014, pre-2014 and 2014, so you can see the difference and see what happens. Let me increase this a little bit. Oh. So as you can see here, this is the 2014 formula, and this was pre-2014. It's treating everyone equally. And then we get to 4.38. In 2014, we get to 44.40. That's how we got that number when we looked at the execution plan. And of course, it doesn't match the actual number, but at least it's a lot better than what was pre-2014 compared to 2014. So we used a AND statement here. Now, if we change it to OR, what happened? In this case, we get 1404.8. And again here, the formula changed. So in 2014, even in the OR clause, they're trying to reduce the effect of the most selective ones, or that qualifies for more rows. So if we look at this formula for both versions, as you can see in 2014, this is the formula, and before it was this, and it gets a little bit closer to the actual numbers. It's 1235 and 1404. It's 1235, 1492. And I cannot guarantee that every time it's going to work in a better direction in 2014. It will probably also depend on the values that you're passing for the predicates, but most of the time you'll see a better or a closer estimation, closer to the actual numbers in 2014 and above. And I also put the code so you can run those same statements using the trace flag 9481. I'm not going to demo those now for the interest of time. Let's look at a store proc. So what I did here, I just created a very simple store proc, select these 4 columns based on the contact person ID. And we've been looking at contact person ID. We've been using it as a predicate throughout the demo. So I just wrap that up in a store proc, and we'll call it And we've been looking at, if we call it with 1025, if you look at in your histogram number 5, it should be 89, because that's the number of equal rows for 1025. We have seen that before also. And in this case, we can see that it's 89, our estimated number of rows. And one thing you might want to look at here, because this is the first time we call this a store proc since we created this. You can see that our runtime and compile time, the value is 1025, which matches. And now, if we call this with 1057, which we did before, and we would expect is between line number 10 and 11, this falls between 1055 and 63, so we should get 118.6667. And let's see what we get here. We still get 89. Now, why is that? So if you look at here, again in the parameter list, you can see that we are compiled with 1025, but our runtime value is 1057. And that's why we still get 89 here, because it was compiled with that value, and the plan in the cache is still there, and it's reusing it. And that's the problem we sometimes get, and we call it parameter sniffing. Now, what we can do, if I say, okay, evict all the plan in the cache, but be careful, if you do it in your test environment, that's okay. But if you're trying to do this in your production server, think twice, because you can always evict individual plans instead of cleaning the whole cache. So now there's no plan for that store proc. And if we call it now, we should see 118.6667. And if we look at here in the parameter list, we can see that it's compiled and the runtime both are same. So let's look at some unknown ones. Before I do that, I'm just going to show you, because we know that in this table order ID is the primary key and it knows that the order ID is unique. So every time you use a column which is a unique and the cardinality estimator knows that, it will always estimate 1 because it knows that it's a unique column. So that's what is expected. Now, if we run this with the 1025, but we are passing this in a variable and it has no idea in the compile time what that value is, we get 111.003. Now, where did this come from? As we know before that 1025 we've been using, it should be 89 records, but we get this 111.03. So what it does is it knows the total number of rows and it knows the density of contact person ID. It just multiply those two and it will use that number for anything you pass there. 111.003 doesn't look at the histogram because it doesn't know what to look for. And next we'll be looking at a table variable. Now I'll show you this in two ways. First, if we don't have the option recompile, the cardinality estimator has no clue how many records are in the table variable, and it will just estimate 1. As you can see here, the estimate number of rows are 1. But if we say option recompile, at this point it will know that how many records got inserted into the table variable, and it can use that information, and you will see that here it changed to 271.284. But why does that number come from? There's also a change between 2014 and before, and in 2014 it's actually a power of total number of rows, a power of 0.5. It was in 2014, pre-2014 it was 0.75. So if you run this with that trace flag that I talked about, you will see the number is way higher, it's 4,468, whereas in 2014 and above it's going to be 271.3. So it's always a raised to the power of 0.5, and I have the code here if you want to test it. For any inequality, so I'm not going to show you every one, I'm just going to show you probably 1 or 2 here. And if we see this number is 22078.5, this number came from, it's just 30% of the total number of rows, 22078.5. I'm not going to run this, but for like, it's always 9% of the total number of rows. And you can run and check for between, there is a change between pre-2014, it was 9%, for 2014, it's 16.4317, and these are all when you pass the value and the value is not known to the cardinality estimator during the compile time. And the last one we'll look at, we only have 1 minute, so try to rush here a little bit. So we know that we have 73,595 rows in the table, and we have a statistics for the column picking completed when, and this column is a date time column. So just look at these numbers. What's the last value? What's the highest key we have is a May 31st, 2016. Now what will happen if I insert some rows at the end with a higher value, 2017-0311. I should have turned that off. So okay, so we did insert 50 records, and now we can see that our total number of rows is more, and our statistics didn't get updated. It's 1241. And now if we do a select using that new value, what's going to happen? Because that's not in our histogram. And you can see here is 34.6329. So where does this number come from? There's also a change between 2014 and pre-2014. So in 2014, what it's doing is the total number of rows multiplied by the, I'll show you, let me run this. Total number of rows and the density of that column, that's how it gets 34. But in pre-2014, it will always assume number 1. And this is a bigger problem. And if you have this problem, I put in a comment, look at 2389 and 2390. It's not guaranteed that it's going to help you, but you might want to you might want to explore those two trace facts. And so let's go back to the slide, and we'll be done in a minute. So this is something, adaptive query processing. It was announced just a few days ago on the April 19th. And I'm not going to talk about it, but I strongly encourage you to go to that blog post and video, which I'll have link when you get the slide, and watch that video and read that blog. It's definitely some fascinating things that's been done in SQL 2017, the vNext. And these are all the resources that I'm going to add. Here is my contact information that you can reach out to me with any questions. And thank you so much. Sharon, back to you.
Okay, thank you, Toyo. I've got one question which would probably take you the rest of your natural life to answer. How does the query optimizer select a plan based on the histogram for a query?
So it doesn't choose a plan based on the histogram. It creates all possible plans based on the histogram, if there is one. If there is not one, then it's going to use those magic numbers that I showed you, like 0.9 to the power of 0.5, and you know, all kind of calculations or all kind of numbers. But once it has possible number of plans, n number of plans, it look at which one is the lowest cost, and it will pick that one. There are other variables based on, you know, what kind of hardware you're running on, what kind of resources you have available, and that's a whole topic that we can talk about. And there are people smarter than me extensively blogged about those. And I also put some of the resources, you know, some you know, White and you know, there's a gentleman from California. You know, they wrote about those extensively. That, you know, how the query optimizer will choose, but in general it will choose the least cost one, because this is a cost-based engine, and it try to give you the correct result with doing less amount of work.
Thank you, Toya. I've got one comment. Thank you for the great fundamental execution plan presentation. And people, I have answered this question 17 times today. The scripts, the PowerPoint, and the recording of the session will be posted by Friday at dba.sqlpass.org on the meeting archives page. if Toyab is going to send me the PowerPoint, his contact slide will be in that. You can just wait till Friday to bug him. One more question. SQL Server includes null values in the index. How are statistics handled for null values?
How statistics handle null values. So it will just pick the range high keys and it will take into considerations. So if you look at my second demo script, or the first one with the second one, and if you run that and look at those numbers, how it got generated, and look at those formulas, I think you will have a better understanding of your question.
Okay, I think that's all we have time for. Again, demo scripts, PowerPoint, session recording by Friday at dba.sqlpass.org on the meeting archives page. Okay, demo scripts, PowerPoint, recording of the session. I think it's time for us to end this meeting, and we're going to have another take on this same topic in the middle of May. I haven't sent out the information yet, but it's a different person is going to speak on the same topic, and I think she will have a completely different presentation. So don't think you've seen it all today. And one more comment for Toyab. Thank you very much for the amazing session. See you all in a couple of weeks. And I'm going to stop the recording and end